Whoa! Look at that plane! I wonder how it flies. In this video, we will explore the concept of aerodynamics. But in order to understand aerodynamics, we first must understand the basic concepts of aerodynamics. Aerodynamics is a subfield of fluid dynamics, which is a subfield of fluid mechanics. Fluid mechanics is a field in physics that applies the laws of forces and motion to fluids, while fluid dynamics is the study of fluids in motion, which is referred to as flow. Flow can either be steady or unsteady, and also can be laminar or turbulent. Aerodynamics is the way the air moves objects around. Airplanes, rockets, and kites all react to aerodynamics. The four forces of flight are lift, weight, thrust, and drag. These forces shift objects. Let's discuss the four forces of flight. Like we mentioned earlier, lift, weight, thrust, and drag are the four forces. Weight is the force of gravity. It acts in a downward direction, toward the center of the earth. Lift is the force that acts at a right angle to the direction of motion through the air. Lift is created by differences in air pressure. Thrust is the force that propels a flying machine in the direction of motion. Engines produce thrust. And drag is the force that acts opposite to the direction of motion. Drag is caused by friction and differences in air pressure. In this diagram presented by NASA, it shows the thrust-to-weight ratio of an airplane. Lift is presented with an upward arrow, while weight is presented with a downward arrow indicating the direction of the forces. Thrust is indicated with an arrow pointing to the left or in front of the plane, while drag is indicated with an arrow pointing to the right in the back of the plane. The ratio of thrust to weight is equal to the mass of the aircraft times the acceleration over the mass of the aircraft times the gravitational acceleration, which can be simplified to acceleration over gravitational acceleration. A high thrust-to-weight ratio indicates a high acceleration or high climbing rate of the aircraft. Now that we know the basic forces of flight, let's discuss takeoff and landing of aircrafts. Takeoff in an airplane requires airspeed. The airspeed is a measure of how fast the air is flowing over the airplane, not a measure of how fast the airplane is traveling. If the airplane is flying into a headwind, for example, its airspeed is increased, which is why airplanes generally take off into the wind. Airspeed creates lift across the wings. The wings have a curvature, or camber, that increases the distance the air has to travel over the top of wing. This creates the Bernoulli effect. The Bernoulli principle states that pressure in air decreases as the speed of the air increases. Faster air over the top of the wing lowers the pressure, and the difference created between the top and the bottom of the wing creates lift. Landing an aircraft is much like the opposite of taking off. Wind speed and direction are very significant factors in landing. The illustration explains why it is always practiced to take off and land into the wind. With a headwind of 10 knots and an aircraft indicated airspeed of 70 knots, the ground speed is equal to 60 knots. With a 10-knot tailwind and the aircraft indicated airspeed at 70 knots, the ground speed is 80 knots. It is better to take off and land with a lower ground speed than the aircraft indicated speed. Thus, the headwind is better for takeoff and landing than the tailwind. Now we know everything there is to know about aerodynamics. Well, not quite, but for the purpose of this video, yes. We have learned about the four forces of flight, which are lift, weight, thrust, and drag, and how they affect aircrafts in motion. We have also learned about how an aircraft takes off and lands. I hope you have found this video helpful. This is Christina Vosnak, signing off.